Hey guys, this is Saptarshi here and I welcome you to a video tutorial on chi-square and its application in machine learning and data science. So let's get started with an example. So I'm sure you know this picture. This is the famous Titanic ship, right? And the data set corresponding to this Titanic ship is called as shipwreck data, which is equally popular among the machine learning community. So this is taken as a classification problem. So there are several attributes for a passenger. So here, each of the row belongs to a passenger, and the status 0 in the survived column means that he did not survive. And if it is 1, that means he has survived. So the classification tasks is that given the different demographic variables of that passenger, can we build a model which can say whether the passenger will survive or not? Okay. So there can be some simple problems around it. One problem is, does the sex of the passenger has a role to play in the survival status of the passenger? Okay. So is there a chance that, the female survive more or the male survive more? So this type of questions. Okay. So if I try to answer such a question, the first step can be just to draw a table like this, right? So you have male, female, you have the not survived and survived corresponding counts. Okay. And again, the next step can be just to visualize. So if you visualize, so this is the female part and this is the male part. And you can see, looking at this blue and amber bars, which represents not survived and survived, the patterns are quite dissimilar, right? So we understand that there is a difference, okay, as far as, or there is an association on the gender with the survival fate. However, that is not good enough, right? So for that, we need to look at it mathematically or statistically. All right. So first what we do is we simply just go and calculate the row total and column totals. Okay. And then what we try to do is we try to test independence. So let's try to understand what we mean by independence. So if the gender and the survival status are completely independent, that is the gender doesn't influence that, then we see that the ratio of survived is around 34%. Okay, so 449 survived out of 1313, which turns to be 34%. How many females are there? So we have around 463 females. So 34% of 463 turns out to be 158. So indeed, if it was independent, then 158 of the female would have survived. However, the number is 307. Okay. So similarly, I can find this number under independence, which we call as expected count for all the 4 numbers. Okay, we can do that. So we just do that. Okay, and what we do is we find now the chi-square statistics. So how do we calculate the chi-square statistics? So whatever you get from the data, you call it as observed. Okay, and whatever you calculate under the assumption of independence is your expected count. Okay, so you find the difference, take a square and divide it by the expected count. So if I do the calculation for this particular one, then I will land up with a calculation like this. So I have found out the observed, or the observed was already there from the data, and using this concept we have found the expected values. And then using this formula, so 307 minus 158.33 square by 158.33, I get a value like this. Okay, and if I add them up, if I add all these 4 up, I get a value of 327. Okay, so just one thing I would like to mention over here is that when you create a table like this without the total, that table is called as a contingency table. Okay, and please understand that here the contingency table, the matrix is 2 into 2, but however it is not necessary that it has to be 2 into 2. Okay, so it can be 3 into 3 and so on and so forth. Okay, all right. So now let's see that how we can set up the hypothesis in terms of statistical terminologies. So the null hypothesis is that gender has no association on the survival status. Okay, and alternative hypothesis is that they have association. Okay, so at least I think by common sense you have already understood that the chi-square value should be as small as possible, because if there is if there is indeed independence, then the observed value and expected value should be very very close. If the value is big, that means that the alternative hypothesis or the probability of alternative hypothesis will go up, right? Okay, so this is chi-square distribution, and basically this is a family of distribution. So there is a concept called as degree of freedom, so which I will come in a little while, and based on the different degree of freedom you have different probability distribution curves. Okay, so let's now look at the probability distribution table. So there are different degree of freedoms noted over here, and these are the corresponding p-values, right? So p-value is probability of the null hypothesis being true given the data, right? So what is the null hypothesis? That they don't have any association. Okay, uh, so now if I find the if I look at the chi-square value, which was around 327, you can understand that will be quite far away. So the p-value will be very very small. That means that the null hypothesis is not true and you accept the alternative hypothesis. Okay, so how do you calculate degree of freedom? It is calculated as r minus 1 into c minus 1, where r is number of rows and c is number of columns. So in this case it will be 2 minus 1 into 2 minus 1, so it will be 1. All right, so when you will look at the much more than that, so you can safely accept the alternative hypothesis. All right, now let's look at another interesting scenario where we will look at importance of words in case of text classification. Okay, so when we are looking at machine learning, one of the problems that we have seen is that we want to classify an email as a normal email or a spam email. Okay, so it is not a numerical tabular data like Titanic anymore. So we have emails. So first thing that we will have to do is we will have to present it in a table. Okay, the most simple way of representation is something like this. So for each of the emails, you constitute a row and you count the number of words present in it. Okay, so this means that this was a spam email and word 1 was not present, word 2 was present twice, and word in was present 1. Okay, so as many emails are there, that many rows you will have, and as many distinct words are there, you will have that many columns. So this is also called as the vocabulary. All right, so there are several pre-processing which can be applied, but that is not within the scope of the discussion for chi-square. Now, what we try to do is we try to find a corresponding contingency table for the words here. So how do we do that? So what we can do is, let's say we are looking at the word free. Okay, so what we first find out is that how many emails are there, okay, which has the word free and they are spam. Similarly, I find out that how many emails are there which has the word free and they are normal emails. Okay, and then we also look at that where there is no free, okay, how many such emails are there that doesn't contain the word free. So there are 1,000 such emails, and there are 20,000 such emails, okay, which is from normal email and doesn't contain the word free. Okay, so how do I get the chi-square value over here? All right, so let's put some terms here. So we call this as P, we call this as Q, we call this one as M, and this was as N. Now the chi-square value is given like this. Okay, so where D is the number of documents. Okay, so now let's see that, okay, we find the chi-square value, how we relate this to finding the important one. All right, So one thing that is to be noticed is, so especially when you are interested in doing some research, when you are looking at chi-square with a degree of freedom 1, okay, which is even the case here, that is not a very stable distribution. So often you apply something called as Yates correction. So I'm not discussing what is Yates correction, but whoever want to use chi-square for your research purpose and degree of freedom is 1, one question from your reviewer can be that, have you considered Yates correction? Okay. So now what can be done is that, so these chi-square values can be found out from the words, and you can find out important words based on the value of the chi-square. More the value of the chi-square, more important they are. How do I take this to multi-class, right? So one of the alternative can be that we calculate 2 by 2 matrix for each class, okay? And then either compute the average of the chi-square or the maximum of the chi-square, and then we pick the top words. So basically, I can have a table like this. So this table actually came from 3 contingency tables. So first, what we did is we found a contingency table for sports and not sports, then with crime and not crime, and then with entertainment and not entertainment. So basically here, the documents are news articles. And what is the task? We want to classify, which genre of the article that is it sports, crime, or entertainment. Okay, so let's say we have a term like and, okay, and we see that the chi-square value is very, very small, so you know that your null hypothesis is accepted. So knowing the word and doesn't help to classify or to find out whether the news is sports, crime, or entertainment. However, if you look at the word cricket, you see that for sports, you have a good chi-square value. Of course, you will have to look at the degree of freedom and the level of significance. However, for crime and entertainment, you do not have much high value. Okay, so you might wonder that for cricket, can I get any value in entertainment? Okay, but like the way right now, things are, a lot of cricket news comes under entertainment category. So you can guess, but I don't want to go into that discussion. And similarly, if you look at an word like murder, you see that the chi-square value for crime is high. Okay, so you can either take the maximum of this and decide that whether that word is important or not, or you can take an average and decide on the same. So this way you can take or extend the feature selection that we are doing from a binary classification to a multi-classification. So there are some other use cases. So one of the thing is called as structured equation modeling, which is very, very popular in social science, where you try to find latent models, okay, factors, right? So which you cannot observe. So there, you can have different models. So you can have one model where the other model is completely encompassed in that model. Okay, so such a case you call them as nested model, and the difference between such model can be tested using chi-square. Okay, also one very important application of chi-square is for goodness of fit. So this is heavily used by statisticians. Okay, from a machine learning perspective, what you can do is, so a lot of your algorithms assumes normality, right? Like linear regression assumes that the data is normal. Okay, PCA assumes the data is normal. So in these cases, you can apply chi-square test to find out whether the data is normally distributed or not. Okay, now one thing that you may have noticed is that feature selection, when we have used it for t-test, f-test, okay, so we were dealing with features which were numerical. However, here the features we have looked at are categorical. Okay, so do you think that it cannot be applied for numerical? It can be applied. Only thing that you need to do is you need to discretize the numerical variable, and then you can apply normal chi-square test. Another technique also which is very popular with statistician, chi-ed, is actually a chi-square automatic interaction detector. Okay, so which also tries to find dependence between the attributes and the dependent variable, and gives a visualization in a tree-like structure. So I hope we could give you some of the understandings, okay, of where chi-square is used for machine learning and data science. Okay, so if you have liked the video, if you have find something helpful, please do subscribe and like. If you have any comments, okay, please put it in the comment section. Thank you so much for watching our video, okay, and I hope you will follow our channels regularly. Thank you so much once again.